All right, from what I gather, we're pretty good. I know a couple you missed one here or there. You found mistakes. There you go. All right, hey, listen up. All right, let's finish section 3.3. I should have a little bit of time at the end to get started. Hopefully get pretty far into the homework. We will quiz Tuesday. And all right, on your guided notes, we're going to talk about the remainder and the factor theorems. But first, what I want you to do is take that equation or that function at the top. Go ahead and calculate f of -1, and then calculate f of 2.
I know. Let me guess, you guys recorded her in fourth period.
Of course I did.
Favorite class.
It's been a rough day. I'm sure.
It's okay. We're here for you, Mr. P. Lack. We need everything, we're here for you.
Appreciate that.
We're emotional support.
Especially Ian over there.
Yeah.
He probably kept you thinking.
Pick up the pace. All right, Mason, what'd you get?
I got 6, -1,
Okay.
and then 0 for 2.
0 for 2. Okay, so when you substitute in, you should get f of -1 equals 6, and then f of 2 equals 0. Now, right below that, I want you to use synthetic division to calculate those quotients. So take 2x cubed plus 3x squared minus 11x minus 6. It's the same functions up above. We're going to divide it by x plus 1. We're going to divide it by x minus 2. All right, so for synthetic division, if it's x plus 1, put -1 in the side there in the box. Okay, take your coefficients, 2, 3, -11, -6. Remember, always start with a 0. We add vertically. And so 2 plus 0 is 2. 2 times -1 is -2. 3 minus 2 is 1. I get a -1 here. -12 times -1 is 12. And then you get a 6. All right, you're good just to leave it at that point for now. All right, go ahead and do the synthetic division over there on the other one. And we'll have a 2 to the side. And so I get 2 times 2 is 4. 3 plus 4 is 7. 14. 3 times 2 is 6. Get 0. All right, there is a relationship between those two. We did f of 1 or -1 up above, right? And what did we end up with? F of -1 equaled 6, right? And then f of 2 equaled 0. There, like I said, there is a relationship between those two. Where does the 6 show up in my answer? It shows up as that last term as the remainder. And what do you notice right here for my remainder? It is 0. So that is going to always be the case. So what you do is if you do synthetic division, and I put -1 here, if I divide by x plus 1 and put in -1, like a byproduct will be that this remainder is the same as plugging in f of -1. So if I divide by x minus 2 and I put the 2 here, the remainder is f of 2. So I kind of get some extra information. This is the remainder theorem. Okay. So if you take a polynomial and you divide it by x minus a, then the remainder is given by r equals f of a. Basically, when you plug in that value, that remainder will be your answer. Calculate the following using synthetic division. Now, I realize 9 times out of 10, well, maybe even 10 times out of 10, if you're asked to find f of -3, you're going to take -3 and plug it in, right? Well, we get some extra information, though, when we use synthetic division. Go ahead and do this using synthetic division. Okay. So take -3 over here. And we got 3, -4, 5, and -1. 0 here. All right, see what you get. There's some big numbers here. That's negative. -3. All right, so I got 3 here. 3 times -3 is -9. -13. +39. Add those, get +44, and I get -132 here. And so I get -133. So that means f of -3 is -133. All right, now how does that apply to the division? Okay, what did we just figure out here? Is we figured out that 3x is a cube, yes, minus 4x squared plus 5x minus 1 divided by what? X plus 3. Divided by x plus 3 is equal to 3x squared minus 13x plus 44 plus -133 over x plus 3. It's used more like, so when you're dividing and you test this, you get this answer, then I also know that's the same as plugging in that value. Okay, so that is your remainder theorem. All right, one of the big things when we kind of move through the rest of this chapter is the zeros of a function, and we've already talked about it a good bit. And I kind of move in and out of how I refer to a zero, but kind of the 3 main things. You can call it a zero. You can call it a root. Okay, they're equivalent. And that's the same as the x-intercept. So if I'm ever, sometimes even in a problem, I'll kind of move in and out and say, find the roots, find the zeros, find the x-intercepts. Those are all the same. Okay. All right, now this next part, don't copy this down. But this is where we're heading. Without your calculator, find the zeros of a function that would look like this and graph it. Okay, don't worry about it. It's not on your notes. Okay, but this is where we're heading. So how do we do that without, typing it in your calculator? So you got to be able to find those zeros. And at this point, we don't know how to do that. But that's kind of where we're heading using some of these theorems. All right, now go ahead and flip it over. And the second one we talked about is called the factor theorem. Okay. All right, the expression x minus b is a linear factor. The reason we say it's linear because it's not x squared or it's not x cubed. It's just going to be x minus a number, x minus 2, x minus 4, x plus 2, x plus 4. Is a factor if and only if. Okay, that's not a typo. That's some math jargon there. Means something. If and only if. F of b equals 0. All right, so just it's off to the side here. Don't write anything down yet. what that means, so if x minus 5 is a factor, then what's true, according to that theorem? If x minus 5 is a factor, then what has to be true? f of 5 equals 0. Okay? If x plus 7 is a factor, then f of negative 7 has to equal 0. Well, here's what the if and only if means. It works both directions. So if I start and I tell you that f of 8 equals 0, what can you tell me? Then x minus 8 is a what? Factor. So it works both directions. All right, now let's work at something we kind of, it's easy to work with. All right, let f of x equal x squared plus 10x minus 24. Go ahead and factor that. And then go ahead and put this down. I would put this down in your notes right underneath what you have at the top. So let f of x equal x squared plus 10x minus 24. Factor that. It's just a good old trinomial. What multiplies a negative 24 adds together to give you 10. It's not 6 and 4. Okay. All right, so what do we end up with for that one? Tessa, what's it factor into?
X plus 12 and then x minus 2.
So x plus 12 times x minus 2. Those are factors of the original function. Okay, they multiply together to give me x squared plus 10x minus 24. So I know x plus 12 is a factor. So what does that mean according to the theorem? Since x plus 12 is a factor, what has to be true? F of negative 12 has to equal 0. I know that x minus 2 is a factor. So that means f of 2 equals 0. All right, so understand that connection. And a lot of times what we're going to do is we're actually going to start with substituting a number in and seeing whether it equals 0, and then determine whether that's a factor. Okay. Now, in just a general case, it says show that x minus 2 is a factor of it. Okay. If x minus 2 is a factor, then what has to be true? F of 2 equals 0. So to show that it's a factor, show f of 2 equals 0. Well, don't just plug in 2. Use synthetic division because that gives us some more information that we're going to need at some point. Okay. So use synthetic division with 2 here, and then 1, 1, negative 1, negative 1, negative 18. I do that, and then if it is if it is a factor, our remainder should be 0. Okay, so verify that. And what do I get? I get 1, 2, 3 times 2 is 6. 5 times 2 is 10. 9 times 2 is 18. All right, it does equal 0. So that shows it is a factor. So therefore, x minus 2 is a factor of f of x. All right, what does it mean to be a factor? It means I can multiply it by something to get the answer. So that means that f of x equals x minus 2 times what? What does x minus 2 multiply by to get back the original? Does it make sense? Tyson, do you know what it is? No? All right, maybe I'm not wording it right. What will x minus 2 multiply by to give me the original? Anybody know it?
Is it x cubed plus 3x squared plus 5x plus 7?
It's right here. That's why we do synthetic division. because that is the division, or that is the answer. So it's x cubed plus 3x squared plus 5x plus 9. Okay, so x minus 2 times that whole thing will have to give me back the original. And so then we take a look at the x cubed and we figure out, all right, what's a factor of that one? So we kind of whittle it down. Then that's kind of where we're headed. Not there yet, but that's kind of what we want to do. And right now, as I said, just check this. I told you what to check. Eventually, we're going to have to figure that out. All right, take a look at that last one here. Find the value of k for which the first polynomial is a factor of the second. All right, I want you to use synthetic division. All right, let's think about how we're going to do this. So if I'm checking to see if x plus 3 is a factor, that means f of negative 3 has to equal what? 0. So if x plus 3 is a factor, f of negative 3 has to equal 0. All right, I'm going to use synthetic division. Negative 3's goes here. What goes on the top? Now, this is a little bit different because we haven't dealt with anything with the variables. Top goes the variables, right? Well, the variable of x cubed is 2. Or not the variable, the coefficient. What's the coefficient of kx squared? It's just what? K. Got to put a k. Let's find out what happens. Variable of kx is a k, and then we got a 24. All right, let's see what this is going to look like. Let's go through our normal steps. Add 0 plus 2, which is 2. 2 times negative 3 is negative 6. All right, now, what do I write? What?
K minus 6.
K minus 6. That's really all I can do. I don't know what it is. I don't know what k is. It's just represented as an expression. K minus 6. Take that expression times negative 3. Follow your rules. Negative 3 times k is negative 3k. Negative 3 times negative 6 is plus 18. Add those two together. So that's going to give me negative 2k. That should be an 18. Negative 2k plus 18. All right, what do I do with that? Multiply it by negative 3. So negative 3 times negative 2k is 6k. Negative 3 times 18 is minus 54. All right, what do I get when I add those together? 6k minus 30. Well, make sure you go back and understand the question. Find the value of k. It's k2, it's k5, it's k10, it's k negative 6. We're close, but we're not there yet. If it is a factor, we said f of negative 3 has to equal 0, right? Which means, what does this remainder have to be? 0. So, all right, what's going to make it 0? Just say 6k minus 30 equals 0. Solve for that. So you will force the situation, say, all right, if it's a factor that has to equal 0, make it equal 0. Solve for that. I get 6k equals 30. Divide by 6. K equals 5. Okay, for that. All right, so that's kind of how you go about that. All right, so 2 key things: factor theorem, remainder theorem. Okay, when we're doing synthetic division, whatever this is, that's f of negative 3. And if it's a 0, that means we got a factor. All right, I know you have a little bit of time here. Get done as much as you can. On 48, it's in the book wrong. It doesn't have the x cubed there. Make sure that when you write down the problem, it should say k squared x cubed. Okay, there's a typo there. this not record?
Oh,
Well, let's find out. Nope, it recorded.